In the last video of Module 7, let's talk about the graphic summary. Of course, in the Module 6, we talk about how to using the matplotlib in Python to create different data visualization. But one thing is here, we will really see how the statistic meaning when we make those graphic summary. The graphic summary enables us to visual ascertain the mean, median, mode. That's those measure of search central tendency and deviation and standard deviation and the shape of the distribution we talked about in the previous couple video. So the first one, let's introduce the bar graph. The bar graph is used for the quantitative and the categoric data. A bar graph represents the frequency and the relative frequency of the occurrence for different category of the data. The frequency is represented by the height of the bar. So side-by-side bar graph can be used for comparative analysis. So we see the example. So here we have the data from the class. You have A class and the B class. For different class, they have different students. They're using different transportation to the school. So you see you have train, you have bus, or they're using the bicycle. So that's each student from different class. So when we want to compare how different class using different transportation mode, or how many students use different transportation mode, we want to have the comparison of the different transportation mode. So then we can make the bar diagram, for example. But before we can draw the diagram, we need to reorganize those data. So then we will do for different category. So that's why you can see here, we have the class A and the class B. So then we have different mode. So for the class A, we have 4 students using the bus, 1 using the bicycle, 1 using the train. So that's the total. So then for the class B, the same thing. You have bus students, circle students, bicycle student, or the train. So afterward, you have the count, and also you have the percentage of each road. So this one, each percent is using for the 4 divided by the total students from the class A. So that's we call the percentage of the row. You also have the percentage for the column because we want to know. For bus, you see 50%, more than 50% from class A, they use bus. So then for B class, they have 42.86%. So that's a column. So that's why total usage for the bus will be 100% here. So then, of course, you have your total percentage for each one. So after you have those transportation for the column and the row for the class, so then we can draw our bar graph like this. So this one actually is a combined summary for class A and B for using different mode. So we can see 35% students using bus, 35 students using the bicycle, and 30% take the train. So that's what we call the simple bar. But also sometimes you are not only want to know the total, right? You want to know for the bus, how many students use from class A and class B. So that's why we can change like this. So here you will see we have the cluster bar graph. So the cluster bar graph is the summary for the individual class A and B. Then we using like the cluster. So you see here we have the class A at the beginning, then distribution for the class B using different mode. So out of the students, you can see from here, you can quickly to see from class A, they don't use the bicycle so much. They're using train more. But for class B, most students using the bicycle and they use the train less. So that's what we call the cluster bar graph. And still, you can using the cluster bar graph, you also can have the stack bar graph. So instead, we have the 3 different bars. We're only using one bar, But one thing is we have different modes stacked together, stacked one by one. So this data provide a visual summary that can be used to compare the data across classes as well as within the classes. So still you see the color very big portion from the class B. So that's the bicycle. So then you can see in the class A, your yellow area will be big. So then you will see that will be the trend. So you can see the bar graph usually we're using for the categoric data. Then you have different mode, you have different class. So then here we're just using the frequency to show the relationship with these two variables. The next one, you also have the pie chart. The pie chart also using for the categoric data visualization. So they represent a visual percentage for various categories. The percentage is computed using the circle angle ratio. So the pie chart percentage is the data using the data has the total add to 100%. So for example, you see your circle is 360 degree, right? So then according to your percentage, they just see on each slice how big it is. So of course, from the pie chart, you can see the big range, you will see they will have bigger portion for that. So the pie chart mostly just used for each category is necessary represent as a part of a whole. So whereas the bar chart are using to represent the quantitative that are measured in the same unit, but many may not be part of a whole. So that will be one example of the pie chart. So this pie chart actually is for a company. They have different departments. So then they have their profit. So you can see here, right? So IT will be the maximum profit sector for this current company. The next example we want to show you is the time series. So this time series is a visual plot for the quantitative data that represent a sequence of data points consisting of the successive measurement made over a certain continuous time interval. So that's why we can see the trend and the cycle pattern of the data. So you can see here with our data actually is the company A. They have the different investment amount over different year. So that's why here we kind of using a line chart to draw the time series. So that's why you can see quickly, you can see here is the peak. So here is the very low for the investment. Actually, we have two low points. It's 1970 and 1990 and close to 2000. So the peak actually is before the 1980. So that would be the 1977. So that's why you can see the pattern according to the time very easily. So the next one we talk about histogram. The histogram we're using Python to easily to plot the graph. But here we want to show you how that's really we can manually do that. So histogram is a graphical display for the quantitative data. They're using a rectangle to represent the frequency of the observation in each interval. So each interval we prefer to have that with an even interval. So the histogram, the y-axis mandatorily start at the 0 value. If not, it might provide us with a fallacy view of the data. And the x-axis value sometimes do not start at the 0. Then we're using the break symbol should be employed. So how we will print and how we will do the histogram graph from our data. So we see the raw data here for not a group data. So we have 17 athletes. So that's their mile run. So now what we need to do is how we will represent those data in a histogram. Histogram to represent the different frequency for different mile run. What we'll do, we'll see we arrange the data from low to high. We see they are from 7 mile to the 32 mile is the highest one. So then what we will do is we need to group them. So after we see you have 17 athletes, so now you will see we start from between 7 to 32, right? So that's why we start from 5 to 35. So the interval actually we have the 5.5 and to 10.5. So then we have 30.5 to the 35.1. So then we see how many number in there. So we have 1, 7. So that's why we put the frequency 1. Then we have 2 falling to the 10, between 10 to 15. So then that's where we organize that. So we see here, right, the total is N. So here, of course, you can decide how many group you want. But now here we decide we have 1, 2, 3, 4, 5, 6 group. So in this 6 group, our low to high is 32 and 7. So that's why we're using this one to spread out into 6 different groups. So that's why we have that from 5.5 to the 10.5. So then we have the 32.5 to 35.5 for the highest group. So then you can see here we have the frequency that can be count, or you can using the frequency, using the relative frequency, using the count divided by total count. So that you get the percentage wise. Then how we will graph? The most important thing after you have your frequency, right? So then you have your count. But one thing is we want to graph the histogram like a board. So that's why you need to know the midpoint. So the midpoint actually is the median, the middle point from your range. So that's why 5.5 to 10.5, that will be 8. So where the 8, we will display in that, using that middle to have the frequency 1 to display. So that's why you will see here, that's the first group, you have 1. Second group, you have 2 data. So then 3, 5, 5, 1. So see each group, you have display like that. So to help us to see the histogram is, we can see the frequency for each group we will organize. They can show very clear, we see in that range you only have 1. So then we have most range is between the 20.5 to 30.5. But one thing is that recalculate the average. Like earlier we say, in this range, you between 5.5 to 10.5, right? So your midpoint is 8. So this midpoint using the 8 times the frequency. So that we got the value is 8. So then here, the second category, you have 2 times the midpoint is 13. So you have 26. So after you add all together, so then divide by 17. So here, the graph to display, the average actually is close to 22. But compared to originally of raw data, that's about 22.05. But that's exact value, 22.5, right? But here, if you're really using this one, 376 divided by 17. So if you really see the decimal, actually they are 22.1176. So you can see compared to the raw data. The raw data actually your origin group mean is 22.05. So that's a little different after we organize the data to display the histogram graph, but they are not really present the raw data. But here is help us for the visualization. The last one in this lecture is a box plot. So the box plot, just quickly to tell you the definition, the box plot is your plot. They have 5 value: minima, first quartile, second quartile,